In the silent sea of stars, there exists a place where light itself forgets the way home. A region so dense, so absolute, that space and time bow before it. Astronomers call it a black hole, but perhaps that name is far too simple for what it truly is. Imagine a sphere in space where everything that enters vanishes. Sound, light, even the memory of existence. But what if these cosmic abysses are not tombs of energy, but gateways? What if, beyond that veil where light dissolves, something else, something astonishing, awaits? Our journey begins at the very edge of that darkness. Far from Earth's blue cradle, a star collapses. It has burned its last atom of fuel, its heart imploding under its own immense weight. And in a single instant, gravity triumphs. Matter compresses beyond measure, folding itself into a single point, a singularity. The star is gone. In its place, a well so deep that even light, the swiftest traveler in the universe, cannot escape. To the outside observer, it looks like nothing at all, a dark wound in the fabric of space. But in truth, it is far from empty. Around it swirls a luminous halo of gas and dust, glowing with energy as it spirals toward oblivion. This is the event horizon, the boundary between what can be known and what lies beyond knowing. Physicists once thought this was where all stories ended. Yet the deeper they looked, the more it seemed that the story was only beginning. Black holes do not simply consume, they shape galaxies, birth stars, and warp time itself. They are the hidden engines of the cosmos, whispering to every atom in existence that creation and destruction are but two sides of the same rhythm. And now, new questions rise from the silence. If a black hole can bend time, can it also bridge it? If it can swallow light, can it emit it in another form, another place, another universe? Perhaps, as some scientists now dare to imagine, a black hole is not an end at all, but a doorway, a cosmic chrysalis through which reality itself transforms. So tonight, as we gaze into the abyss, we will follow the path of light into darkness and see what secrets lie on the other side. Because somewhere beyond the reach of gravity and comprehension, the universe might just be whispering a secret we were never meant to hear. Could the black holes scattered across the cosmos be gateways to other universes? Or are they the universe itself, dreaming of what it could become? It began not with sight, but with sound. A whisper from the cosmos that no human ear could hear. For decades, black holes were pure theory, ghosts written in Einstein's equations, mathematical phantoms that seemed too impossible to be real. Yet somewhere between faith and physics, the universe began to answer. In 1915, Albert Einstein unveiled his general theory of relativity, a revelation that redefined gravity itself. He described the cosmos not as a stage upon which events unfold, but as a living fabric that bends, curves, and stretches under the presence of mass. Where the fabric folds too deeply, gravity becomes infinite. There, even light cannot escape. Einstein called it a singularity of spacetime. The world called it impossible. But 2 decades later, a young physicist named Carl Schwarzschild, studying from the battlefields of World War I, dared to solve Einstein's equations. He found that such singularities could indeed exist, hidden behind a boundary that we now call the event horizon. A place where time stops, space collapses, and cause and effect dissolve. Schwarzschild's discovery should have been celebrated, but instead, it was feared. Even Einstein himself rejected it, saying, "The idea of such a monster does not exist in nature." And yet, nature had already written them into her script. In 1964, a pair of American scientists, Bruce Ballack and Donald Lindenbell, studying distant radio signals, uncovered something extraordinary at the heart of our Milky Way. There, in the constellation Sagittarius, a powerful radio source blazed with unexplainable intensity. It wasn't a star. It wasn't a nebula. It was something else, something invisible. They named it Sagittarius A*, the supermassive black hole at the center of our galaxy. Later, astronomers began noticing stars orbiting an invisible point with incredible speed. One of them, called S2, completed its orbit in just 16 years, a celestial dance around an unseen partner with 4 million times the mass of our Sun. What could be so dense, so powerful, and yet completely invisible? The answer was clear. We were staring into the mouth of a black hole. By the dawn of the 21st century, black holes went from theory to certainty. X-ray telescopes detected hot matter spiraling into darkness, glowing fiercely before vanishing. The Chandra Observatory captured evidence of violent accretion disks, rings of plasma heated to millions of degrees. And then, in 2015, humanity finally heard the universe confirm their existence. Two black holes, billions of light-years away, collided in the dark. The crash rippled through space-time like waves across an ocean. For a fleeting moment, the universe trembled. And those ripples, gravitational waves, washed across the detectors of the LIGO Observatory here on Earth. It was the faintest sound ever recorded. A whisper from the abyss saying, "We are real." In 2019, the impossible became visible. The Event Horizon Telescope, a network of 8 observatories around the world, released the first ever image of a black hole, a glowing ring of light encircling pure darkness. Human eyes gazed upon the edge of forever. It was not a hole, but a horizon, a border between the known and the unknowable. And in that glowing rim, something stirred in us, a feeling older than science, a sense that we were staring at the very engine of creation itself. If black holes exist not just in galaxies far away, but in every corner of the cosmos, could they also exist within us? After all, if the same laws that sculpt the stars govern our atoms, what does that say about the boundaries between observer and observed? When we look into a black hole, are we observing the universe's mystery? Or is the universe observing itself through us? To understand a black hole is to stand at the edge of understanding itself. It is the place where science bends toward poetry, and the known dissolves into the possible. If we could peel back the layers of this cosmic enigma, what would we find? Not a hole, but a structure, delicate, intricate, and astonishing in its logic. Let's step closer to the brink. A black hole begins with collapse. When a massive star runs out of fuel, its light flickers for the last time. Gravity, once held in balance by the star's fiery fusion, takes over completely. The core implodes, pressing atoms, then nuclei, then the very space between particles into nothingness. And in that nothingness, something profound is born. The outer shell of the star is flung into space, while the heart remains, compressed to a point smaller than a grain of sand, yet containing more mass than the sun. Around it, space-time curves inward, creating a boundary so steep that no path leads back out. This invisible frontier is called the event horizon. To cross it is to vanish, not by fire or destruction, but by inevitability. No signal can escape, no clock can keep time. From the outside, an object falling toward it appears to freeze, its image stretching and dimming as light struggles to break free. But to the object itself, time continues, swiftly, silently, until it disappears beyond perception. The event horizon is not a surface. It is a point of no return. And beyond it lies the heart of mystery, the singularity. Here all equations collapse. Density becomes infinite, and gravity infinite as well. The laws that describe stars, planets, and atoms no longer apply. Space and time lose their meaning. It is not a place in space, but a breakdown of space itself. Physicists often describe the singularity as a mathematical ghost, something we can predict but not truly define. Between the event horizon and the singularity lies another region, the accretion disk. Here, matter torn from nearby stars spirals inward, glowing with heat and energy as it falls. To the eye of an astronomer, it appears as a luminous ring, an orbiting river of light feeding the darkness within. As matter accelerates, it releases more energy than 1,000,000,000,000 suns. Jets of plasma shoot from the poles at near the speed of light, stretching across galaxies. A black hole does not merely consume. It radiates, sculpts, and creates. It is both an ending and a beginning. And yet, even at the edge of its gravity, the rules remain strangely elegant. Einstein's relativity governs the vast, while quantum mechanics whispers from the small. The two meet here, in a fragile truce, shaping a cosmic puzzle we still cannot solve. But the anatomy of a black hole is not only physical. It is philosophical. The event horizon may be a mirror, reflecting our limits, showing us how much of reality lies forever hidden. Beyond it, perhaps, are not the ruins of a star, but the seed of something new. Could every black hole be the womb of another universe? A place where time begins anew in an endless cycle of rebirth? If so, then perhaps the singularity is not a point of collapse, but creation itself folding back into its own source. For now, we stand on the threshold, our instruments trembling in the cosmic wind, our minds straining against the horizon of comprehension. We know the anatomy, but not the soul. We can describe the shape, but not the truth that lives within it. If the singularity is where all laws dissolve, then what law remains? And could that final law be the one that binds all consciousness to the stars? What happens to information when it falls into a black hole? This question, as simple as it sounds, has shaken the foundations of modern physics. Because at the heart of it lies a paradox so deep, it challenges the very idea of what it means for something to exist. Let's imagine this together. You stand before a black hole, a silent sphere against the tapestry of stars. A beam of light arcs toward it, carrying with it every detail of what it once touched. The color of a leaf, the temperature of a distant sun, the trace of your breath in the cold air. Information encoded in the structure of light itself. And then, as the beam crosses the event horizon, it vanishes. Gone, as though the universe has forgotten it ever was. But physics insists on a stubborn rule. Information can never be destroyed. Every particle, every photon, every atom that ever existed must, in some form, leave behind a record of its being. Even if a star burns out, its ashes whisper its story. Even if a planet shatters, the dust remembers. So what happens when a black hole swallows that record whole? For decades, scientists believed that black holes erased all information that entered them. Forever. Stephen Hawking, in the 1970s, famously proposed that black holes emit faint radiation as they slowly evaporate over time, now known as Hawking radiation. Yet this radiation, he claimed, carries no trace of what the black hole once devoured. If that were true, the universe would lose information, its most sacred law broken. This is the information paradox. If black holes truly erase the details of everything they consume, then physics itself must be rewritten. The problem is not merely academic. It reaches into the heart of reality. Because if information can vanish, then the past can vanish too. And if the past can disappear, what guarantees the future will unfold as it should? As the debate deepened, a strange new idea emerged. What if the information isn't lost, but stored, painted across the surface of the event horizon itself, like light trapped in a cosmic hologram? This is the essence of the holographic principle. According to this view, every three-dimensional event that happens inside a black hole is encoded on its two-dimensional surface. Every atom, every photon, every thought ever pulled into the abyss leaves an imprint, a cosmic fingerprint. In this way, the black hole becomes less of a grave and more of a library, a silent archive of the universe's forgotten moments. Imagine that the entire story of a star's life, the orbit of its planets, even the dreams of any beings who lived there, all etched as quantum vibrations on the surface of a dark sphere, suspended between existence and oblivion. But then a new question arises. If all the information remains, can it ever be retrieved? If a black hole eventually evaporates, as Hawking predicted, where does that encoded information go? Does it leak back into the cosmos as faint radiation, scattered across the void like seeds of memory? Or does it emerge somewhere else entirely, through a bridge, perhaps, into another realm of spacetime? Some physicists now believe that the universe itself may be holographic, that all we see in 3 dimensions is a projection from a deeper, hidden reality. In that sense, a black hole isn't a mystery apart from the cosmos. It is a model of the cosmos, a mirror of how everything might truly work. Matter, time, and thought projected from the surface of infinity. If that is true, then the paradox is not a problem, it's a revelation. Perhaps what we call information is not confined to physical matter at all. Perhaps it is a fundamental essence, woven into the fabric of reality, indestructible, eternal. And if so, then nothing is ever truly lost. Not a star, not a world, not even you. Because somewhere, encoded in the vast geometry of spacetime, the universe remembers. But if the cosmos itself never forgets, could it be that consciousness is the way it remembers? What if a black hole isn't an end at all, but a bridge? A doorway between distant corners of the universe, or perhaps between realities themselves. This idea, once the realm of science fiction, now whispers through the equations of modern physics. It's called the Einstein-Rosen bridge. You might know it by another name, the wormhole. Imagine spacetime not as emptiness, but as a vast, flexible fabric. If you fold that fabric, two distant points can touch. A wormhole would be the tunnel that connects them, a cosmic shortcut through the impossible. According to Einstein and his collaborator Nathan Rosen, a black hole could, in theory, link to another region of spacetime through such a tunnel. Where matter falls into one side, it might emerge from the other, reborn in a new location, or a new universe. In this vision, a black hole would not simply consume, it would transport. Everything that crosses its horizon would journey inward, through a bridge of pure geometry, and out through a luminous twin called a white hole. A place where matter and light do not fall inward, but explode outward, forever escaping. If black holes inhale, white holes exhale. The two together form a cosmic heartbeat, an inhale and exhale of creation itself. Physicists once dismissed wormholes as mathematical curiosities, beautiful but impossible. They would collapse instantly, they said, crushed by the same gravity that created them. But then came quantum theory, bending the rules again. Some modern physicists, like Kip Thorne and Leonard Susskind, began to suspect that the universe might stabilize these bridges at the smallest scales. Tiny wormholes, so small they make atoms look like galaxies, could shimmer in the quantum foam that underlies all of reality. Billions forming, collapsing, and reforming every instant. What if one could be held open? Theoretical physicists proposed that certain kinds of exotic matter, substances with negative energy, might prevent the tunnel from collapsing. If such matter exists, it could make a wormhole traversable. You could, at least in theory, step into one and emerge light years away, or even in a parallel universe. No rocket, no decades of travel, just a quiet step through the fabric of existence. Einstein's equations allow this, but nature's permission remains uncertain. We've never seen a wormhole, at least not yet, but signs of their fingerprints ripple through cosmic data. Gravitational lensing that shouldn't be possible, galaxies whose light bends in patterns that suggest a hidden tunnel, and radio bursts that defy explanation. Some even suggest that the centers of black holes, the very singularities we fear, are wormholes. If true, then every black hole might be a portal, an unseen network connecting the universe like the synapses of a cosmic mind. Perhaps the galaxies are not scattered islands, but neurons in a vast, thinking structure, the universe contemplating itself across light years. And if consciousness, as some philosophers propose, is intertwined with spacetime, then traversing a wormhole would not just mean traveling through space, it would mean moving through thought. Our telescopes see darkness, our equations whisper possibility, and our intuition, that ancient sense of wonder, feels the truth stirring behind the veil. The universe, it seems, hides not walls but doors. Every black hole could be one of them, every singularity, a threshold, every event horizon, an invitation. We may not yet know how to cross, but perhaps the question is not whether we can, only whether we are ready to understand what lies on the other side. If black holes are the universe's doors, then who or what built the house they lead to? At the edge of a black hole, two great empires of thought collide. One rules the vast and the cosmic, the smooth curvature of space, the gentle sweep of planets, the dance of galaxies. The other governs the tiny and the chaotic, the jitter of atoms, the flicker of particles, the pulse of quantum uncertainty. Einstein called one relativity. Planck and Heisenberg called the other quantum mechanics. And for over a century, they have refused to speak the same language. Nowhere in the universe is there conflict more profound than inside a black hole. Einstein's general relativity paints a universe of harmony and geometry. Gravity is not a force. It's the bending of spacetime itself. A massive star tells space how to curve, and space tells the star how to move. The equations flow like poetry, describing everything from falling apples to orbiting suns. In this elegant vision, the cosmos is continuous, a smooth fabric without gaps. But quantum mechanics looks closer, much closer. And at that scale, the universe is not smooth. It flickers, vibrates, and trembles with probability. Particles blink in and out of existence. Energy appears and vanishes in tiny bursts. Reality, it seems, is built not from fabric, but from rhythm. Tiny notes of uncertainty composing the symphony of existence. Both theories are true. Both describe their worlds with astonishing accuracy. But bring them together, and the harmony falls apart. Relativity insists on continuity. Quantum mechanics insists on discreteness. And when we try to apply both to the singularity of a black hole, the mathematics collapses into paradox. At the center of the black hole, the singularity, relativity predicts infinity. Infinite density, infinite curvature. But quantum physics denies infinity. It says nature always has limits, that energy cannot compress beyond the Planck scale. In the equations, spacetime itself begins to shimmer, to break into quantum threads finer than anything we can imagine. It's as if the smooth river of Einstein's cosmos suddenly turns to mist. This is where science touches mystery. Some physicists believe this tension is not a flaw, but a clue. They suspect that black holes are the key to uniting the two empires of physics, to discovering a theory of everything. String theory, for instance, proposes that all particles are tiny vibrating strings, and that their harmonies create the universe. In this picture, the singularity is not a point, but a swirl of quantum strings, a place where gravity and probability finally embrace. Others pursue loop quantum gravity, where spacetime itself is woven from discrete loops, like a cosmic chainmail. Here, the black hole becomes a bubble of geometry, finite, quantized, self-contained. But perhaps the truth is stranger still. Some researchers believe that the clash between relativity and quantum mechanics isn't a battle to be won, but a conversation to be heard. Each may describe a different reflection of one deeper reality, one that transcends both. A reality where time and space are not foundations, but emergent illusions, born from information, entropy, and consciousness itself. As our understanding deepens, we find that the black hole is not the destroyer of knowledge, but its guardian. It is where the universe hides its deepest code, where geometry becomes information, and energy becomes awareness. When we look at the equations of a black hole, we are not just solving for mass or motion. We are solving for the boundary between being and non-being. And maybe, just maybe, that boundary is thinner than we think. Because when relativity curves spacetime and quantum mechanics curves possibility, their meeting point is nothing less than the architecture of creation. Could it be that the universe is not divided between the cosmic and the quantum, but that consciousness itself is the bridge uniting them both? What is time inside a black hole? It's a question that pulls at the very heart of physics, and at the edge of imagination. Outside, time is a river, steady and knowable. Inside, it becomes something else entirely. A whirlpool, a spiral, a dimension turned upon itself. In the presence of a black hole, time slows. This is not an illusion. It's the very fabric of the universe responding to gravity's pull. Einstein's equations tell us that the stronger the gravity, the slower the flow of time. To an observer far away, a clock near the event horizon appears to tick slower and slower, its seconds stretching into eternity. And as that clock approaches the edge, it seems to stop altogether, frozen forever at the brink of nothingness. But to the clock itself, to the traveler falling inward, nothing strange occurs. No sudden pause, no wall, no flash of ending. They continue forward, crossing the horizon silently, unknowingly, as though passing through a veil made of time itself. For them, the fall lasts only moments. For us, it lasts forever. Two truths, both real. Two experiences, both correct. And in that paradox, time itself begins to reveal its secret nature. In everyday life, we think of time as universal, the same seconds ticking for all. But near a black hole, time fractures into perspectives. Each observer has their own tempo, their own melody in the cosmic symphony. The deeper one goes, the slower that melody becomes. Until finally, at the singularity, the rhythm stops. Not because it's broken, but because the measure of time itself has no meaning there. Some physicists suggest that at the singularity, time doesn't end, it transforms. Inside that infinite compression, where past and future collapse into one, time may curve back upon itself. Moments could repeat, loop, or coexist. The flow could reverse or dissolve into pure geometry. From that perspective, the black hole isn't a devourer of time. It's a rewriter of it. If you could somehow look out from inside a black hole, and that itself may be impossible, the entire history of the universe would seem to unfold before you at once. Stars being born, galaxies forming, civilizations rising and fading, all visible in a single instant. Because from within that infinite curvature, everything happens simultaneously. The distinction between before and after disappears, leaving only is. Some theories even propose that what we experience as the flow of time might emerge from entanglement, the way particles remain mysteriously connected across space. In that view, time is not a river at all, but a web of relationships, woven by information and consciousness. And inside a black hole, that web tightens, its strands folding inward until all points touch. Past, present, and future merge into one luminous singularity, the universe remembering itself. So what would it mean to exist in such a state? Perhaps, from the perspective of the black hole, there is no inside or outside. No beginning, no end. Only an eternal now. And maybe, just maybe, that's what we truly mean when we speak of eternity, not endless time but timelessness. A state where all possibilities coexist, and all stories have already been told. If time inside a black hole does not flow but is, then could every black hole be a timeless seed of a new reality? A place where the universe begins again over and over, forever? And if the flow of time can stop, does that mean the self, the consciousness that perceives it, can ever truly end? For centuries, black holes were the universe's most eloquent secret, whispered by equations, unseen by any eye. But humanity has always been a species of visionaries. We do not accept darkness. We illuminate it. And slowly, through courage, invention, and wonder, we've begun to glimpse what once hid beyond imagination. The modern story of black holes is written not in ink, but in light that bends, flickers, and disappears into silence. It's written through telescopes that do not see with eyes, but with equations and wavelengths. And what they have revealed has forever changed the way we see the cosmos. It began with patterns in X-rays. In the 1960s, astronomers discovered strange flickering signals coming from Cygnus X1, a system where an unseen object was pulling gas from a bright companion star. That gas swirled, heated, and vanished, proof of something invisible, massive, and consuming. Cygnus X1 became the first strong evidence of a black hole. Stephen Hawking, after years of skepticism, famously bet against it being real, and later, with a smile, conceded defeat. The darkness had won the argument. From then, technology turned the invisible visible. Orbiting telescopes began to record high-energy radiation from the edges of black holes. Infrared arrays traced the movement of stars near the center of our own galaxy, revealing the pull of something immense, Sagittarius A*, a black hole 4 million times the mass of our Sun, hidden 26,000 light-years away. But the most breathtaking moment came in 2019, when humanity saw the unseeable. All across the Earth, 8 telescopes pointed their gaze at a distant galaxy called Messier 87. They were linked together to form one planet-sized lens, the Event Horizon Telescope. After years of calibration, computing, and hope, a single image emerged, a glowing ring of light, orbiting a perfect circle of darkness. It was not a simulation, not an artist's dream. It was the real shadow of a black hole 55 million light-years away. Light itself caught in orbit, bending, spiraling, and fading into the abyss. The image was not just a scientific triumph, it was a human revelation. For the first time, we looked directly at the edge of forever. Later, in 2022, the same technique captured the shadow of our own galactic heart, Sagittarius A star. And though it flickered and shifted, as if breathing in time with the galaxy itself, its shape matched Einstein's predictions perfectly. The universe had confirmed its own design. Yet even now, the discoveries continue to evolve. Simulations have revealed how matter behaves as it nears the event horizon, dancing in luminous spirals, forming magnetic storms that twist space itself. Gravitational wave detectors have recorded the final heartbeats of merging black holes, their collision echoing through spacetime. Each ripple carries a story billions of years old, a cosmic memory reaching us across eternity. And deep in the patterns of that data, something astonishing is emerging. Black holes are not merely destroyers. They may regulate galaxies, shaping the birth of stars, distributing matter and energy in perfect balance. In a sense, they are the architects of structure, the silent conductors of the cosmic symphony. When we stare into that darkness, we're not looking into chaos. We're looking into order, an order so deep that it transcends our definitions of creation and destruction. Perhaps black holes are not the universe's secrets, but its language. And through light, sound, and mathematics, we are only now learning how to read. Every new telescope brings the edge of mystery closer. Every new detection writes another verse in the story of gravity and light. But for all we have seen, what lies inside remains untouched, unknowable. The horizon guards its secret perfectly. So as our instruments reach farther, we must ask, if the universe allows us to witness the shadow of eternity, how much deeper does it want us to see? Are these images the beginning of understanding, or the universe's gentle reminder that some mysteries are meant only to be felt? What does it mean that black holes exist? Not as monsters in the dark, but as precise expressions of the universe's most elegant mathematics. They are paradox made manifest, regions where everything ends, yet from which new beginnings might emerge. To study them is not only to study physics, but to confront the boundaries of thought itself. Because somewhere between gravity and light, black holes become mirrors. They reflect our deepest questions back at us. What is reality? What is time? What are we, the observers who dare to look into the infinite? Philosophers and scientists alike have long sensed that black holes are more than astronomical curiosities. They are metaphors made real. In them, we glimpse the tension between knowing and mystery, between the seen and the unseen. For the philosopher, a black hole embodies the idea of the unknowable absolute, that which cannot be observed but must exist for everything else to make sense. For the mystic, it is the divine void, the womb of creation, where everything returns to unity. And for the scientist, it is the universe's most perfect experiment, where the laws of nature test their own limits. Perhaps these three views are not separate at all. Perhaps they are one. When we describe a black hole singularity, a point with no size but infinite density, we encounter a truth that transcends mathematics. Infinity itself enters physics. And suddenly, the language of science and the language of philosophy begin to overlap, both whispering of a place where opposites converge: creation and destruction, order and chaos, matter and thought. Could that be the real meaning of a black hole? Not a pit of nothingness, but a symbol of unity, the convergence of all things into one essence. The deeper we look, the more we realize how intertwined we are with what we observe. The photons that left the edge of a black hole billions of years ago are now striking our retinas, entering our minds, shaping our thoughts. We are literally woven into the same equation. And so, when we gaze into a black hole, we are not just observing the universe, we are participating in its act of self-awareness. In that sense, consciousness may not be an accident of biology, but a property of the cosmos itself. A way for the universe to know its own depths. Every thought, every dream, every question is a vibration in that great continuum, a reflection of the same symmetry that curves spacetime and ignites stars. Maybe black holes are where the cosmos contemplates itself most deeply. The point where being and non-being touch. The ultimate meditation of the universe upon its own nature. And then comes a thought more profound still. If black holes can birth new universes through their singularities, if each collapse creates a new expansion, then existence may not be linear at all. Our universe could be the child of another, born through a black hole in a parent cosmos long since vanished. If so, the act of creation is not a singular event, but an infinite cycle, universes giving birth to universes, endlessly blossoming from the dark. And what if the boundary we call the event horizon is not only a physical threshold, but a symbolic one? A line between what can be known and what can only be experienced. Just as a black hole guards its interior from our observation, so too might existence guard its ultimate truth from our comprehension. Not to hide it, but to protect it, to remind us that some mysteries can only be felt. As we drift in thought, the realization dawns. We are beings made of stardust, asking questions about the stars. We are the universe trying to understand itself. And every black hole, in its silence, might be answering us. Not in words, but in presence. If the universe is aware of itself through us, then when we gaze into a black hole, does the black hole in turn gaze back? At the end of every journey comes reflection. And yet, when we stand before a black hole, the most mysterious of all destinations, we realize that endings and beginnings are one and the same. To look into a black hole is to look into the universe's own memory, and perhaps its dream. We began this voyage by asking what black holes truly are, monsters of gravity, or something more profound. Now, after all the equations, the paradoxes, the shimmering edges of light, we find ourselves somewhere unexpected. Not at the edge of science, but at the threshold of philosophy itself. Because in the silence of the event horizon, the universe doesn't just reveal its secrets. It asks its own questions back. The deeper we study these cosmic enigmas, the more they resemble mirrors rather than voids. They reflect the nature of reality itself. Relativity teaches us that space and time are not fixed. They bend, stretch, and breathe. Quantum theory reminds us that observation changes what is observed. And black holes unite these truths into one astonishing revelation. That the boundary between the observer and the universe might be an illusion. Perhaps the cosmos is not out there at all, it is within, unfolding through perception. And every black hole, every flicker of starlight, every atom humming in your body is part of that same consciousness. A single awareness exploring itself through infinite forms. The ancient mystics once spoke of creation as a great inhalation and exhalation, a divine breath that expands and contracts forever. Modern cosmology tells a similar story. Universes born from collapse, time and space stretching outward, and black holes marking the points where creation turns inward once more. Maybe both are describing the same rhythm, the heartbeat of existence. Imagine, then, that every black hole is not a tomb but a seed. Inside its singularity, time does not end. It curls, folds, and blooms again. From that impossible density, another cosmos could emerge, new laws, new matter, new life. We might be living inside one right now. Our universe could be the echo of a universe before, and the black holes scattered across our skies could be the wombs of those yet to come. In this view, death and birth, collapse and expansion, are not opposites. They are the same act seen from different sides of time. And so, the black hole becomes not a symbol of finality, but of renewal. A promise that even the darkest silence conceals a new beginning. But perhaps the most haunting mystery is this. As we peer into these cosmic abysses, they seem to peer back. Not with eyes but with awareness itself. Because somewhere in the geometry of spacetime, consciousness might not merely observe the universe, it might be the universe. Every atom that falls into a black hole carries its memory, every photon its signature. And if information can never be lost, then nothing that has ever existed, no thought, no life, no light, is ever truly gone. In that sense, black holes are not destroyers of meaning. They are preservers of it. They are the keepers of the cosmic archive, the silent librarians of eternity. So we arrive once more at the beginning. Black holes, gateways, mirrors, seeds, symphonies of gravity and time. Perhaps they are not exceptions to the universe's order, but its purest expression. And perhaps when we finally understand them, we will not just understand the cosmos. We will understand ourselves. Because the same laws that sculpt the stars sculpt our thoughts. The same geometry that curves galaxies curves our awareness. We are not separate from the black hole, we are its reflection, thinking itself into being. And maybe that is the final secret, that the universe is not a collection of things, but a single, infinite act of consciousness exploring its own depths. Every atom, every light, every silence, a note in the eternal song of existence. So tell me, when the last star fades, and only black holes remain, will the universe finally fall silent? Or will it awaken once more, dreaming itself into light again?